Alrighty, guys. I would like to work an example of adding two fractions and adding two fractions where I have different denominators. Okay. In class, we looked at one. We had a multiplication problem. This was from written homework too, and so this actually became an addition problem with the same denominator because multiplication, remember, is how many of what. So in other words, I'm adding up this value. That's my of what. And how many times am I adding them up? 3. So this was 2/5 plus 2/5 plus 2/5. Okay? So essentially became an addition problem. And the way we did that was we'll locate 2/5. So how did we do that? First establish a whole. So 0, 1. I actually went all the way from 1 and then to 2. I split each whole into 5 equal segments. And then once I did that, I could locate where the original 2/5 lived. And then I just needed to take 1, 2, 3 jumps of length 2/5, and then wherever I land was my answer. And so you can kind of interpret that two different ways. You could think of you're going to start at 0 and then jump to the first 2/5, and then from there jump another 2/5, so whatever that distance would be, and then from there jump another 2/5. Okay? Or another way is sort of just start here right off the bat, and then jump 2/5, jump 2/5. And without drawing it here, because we've already did this problem, let me talk our way through how addition works, sort of based on our 107A definition. So our 107A definition of addition, at least when I taught 107A, was just the phrase altogether. In other words, it wasn't really like a big mathy formula. It was just count everything up all together. So let's say I've got 2. Let's call these markers fifths. Why not? So I've got 2/5. And then I combine those all together with another 2/5, and then I combine those together with another 2/5, right? So each marker is fifth. So how many markers do I have here altogether? 2, 4, 6. So I've got 6 of them. What do I have 6 of? Fifths, right? I was calling them fifths. So in the denominator, that explains why once we have the common denominator, we can kind of keep that because that's really describing what we're adding up or what we're collecting all together. All right? And is that fair to think about? Sort of, because as you're jumping down the number line, you're sort of collecting segments, right? So I have 2 segments, then I collect another 2, or jump past another 2, jump past another 2. And those segments are fifths because there were 5 of them in our whole. All right. So if you've got the common denominator, we're essentially just adding up the numerators or counting up the numerators all together. So that's not really that bad. Here I'm not showing it on the number line, although if I were doing this as a homework problem, I probably would. But we did that in class, and you guys did that previously. Okay. So that's that one. In this problem, I've got different denominators, right? A 5 and then a 4. So let's think about what you might be thinking to yourself. You're thinking, you're a college-age student, you're thinking, I need common denominators, right? I'm going to add these two fractions together. That means I need a common denominator. And so that idea, that concept is true. On the number line, we're going to want to sort of get the sense of these common denominators. So then we can jump from one point and jump forward the other one and keep everything sort of straight. However, the thing that we're not going to do at this moment in the semester is just simply start multiplying numbers over here and multiplying numbers over here and just sort of magically get the common denominators and then just add them. We want to show those denominators in our number line. Okay, so let's jump in and see how that can work. So let me locate 3/5. Let me use this ruler. I'm going to come out, maybe longer than my eraser, I'm going to come out 6 inches on this 5-gallon paint stick, which is what I use to measure with if I want to sometimes. So here we go, 1, 2, 3, 4, 5 segments. Let me put 5/5 right there and locate a 1. Okay. And now I need to locate 3/5, right? That's going to be sort of my starting point. And again, I can think of 0 jumping to 3/5. So here I've got 1/5, 2/5, 3/5. Okay, there we go. So I need to either go from 0 up to 3/5, but however you want to think about this, at some point I'm going to be here, and I need to jump forward whatever 1/4 is, whatever that length is, okay? So how am I going to do that, though? How am I going to show that? There's, I guess, a couple different ways where we could do this. I think it's going to be helpful to locate 1/4 on the number line. Even though, because, well, let me say, once we do that, then if we take a chunk of 1/4, we can sort of visualize moving it, right? Because we want to figure out what a jump of 1/4 will be. and start here and figure out how far to extend to the right. That's the idea. I'm not going to do it as loosely as sort of just like moving my hands and eyeballing the answer, though. I want to have tick marks broken up so we can exactly count however many pieces I need. And so when I land somewhere, I land on a pre-drawn tick mark that will give me my answer. Okay. So let me locate 1/4. And so the usual way of locating 1/4 is I've got a hole here that I've got to split into 4 equal pieces, right? And we've done this drill a few times. I know I've got 1, 2, 3, 4, 5 pieces already. So if I start, I can't, with 5 pieces, I can't just simply locate, these tick marks don't line up with, they wouldn't split that up into 4 pieces. So I've got to start drawing new marks. And so whenever we draw new marks, what we're doing is breaking up these, what I call original segments, into smaller segments, right? So each one of this original segment will become a group of smaller segments. So I've got 1, 2, 3, 4, 5 originals. That means I'm going to end up with 5 groups of small segments. So if I'm doing 5 groups, I'm going to have 5 groups of some number, right? So it always kind of works out this way. And I ultimately need enough pieces, whatever my total is here, I need enough pieces so then I can form 4 equal size groups based on those total number of pieces, okay? This 4 will work. So if you take one denominator and then use the other one and sort of backtrack out of this assignment for a second and think if you are getting a common denominator here, what are you multiplying, right? If you're trying to take advantage of a shortcut, what are we multiplying? So we're not using the shortcut, but maybe we can see sort of like, oh yeah, that's why we multiply, right? That's where that multiplication comes from. Because if I can form 5 groups of 4 small segments in here, then I've got 20 small segments. And once I locate, or if I have 20 small segments, then I can form 4 equal groups, right? 4 groups of 5. In that case, I'm really doing 20 divided by 4, grouping. So forming 4 equal size groups, and how many little segments will live in the group? 5, right? So we kind of play around a little bit like that. Okay, so let's jump in. So I want to split each one of these 5/5 into 4 equal length segments. So I will put a mark in the middle and then split like that. Mark in the middle and split. A mark in the middle and split. And all the way down. Okay. And at this point, sometimes I like to emphasize or re-emphasize those original blacks, just so we can see the fifths as well as these new smaller segments. Okay. So I still see 1, 2, 3, 4, 5 black segments. I didn't lose that image. And now I see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20 little, what I call red segments, even though the red and the black marks sort of section them off, right? So there we go. We've got the 20 small segments. And did I have to count them? Or could I have just claimed that I've got 5 groups of 4? Either way, right? But when in doubt, counting doesn't hurt, and we label that there for reference. So if someone's looking on, without having to count it, we can see what's going on there. Okay. Let me locate 1/4 here. So I want to locate 1/4, which means, again, I take that to mean I want to see 4 equal segments. I don't just want to put numbers. I want to actually see them. So I'm going to use blue here, kind of maybe a different style tick mark just on the top. And so I erase it though, but I've got 20 little segments. And if I want to form 4 equal groups, then I'm doing division by grouping, right? So I'm basically splitting that up into 4 equal pieces. And so 4 equal groups of 5 little pieces, okay? So let's start counting. And you should know, that should be obvious in a way, because 4 times 5 gave us 20. If you start grouping up, instead of collecting 5 little segments, if you accidentally collect 4 little segments, then we're back in the black marks, right? So we don't want to do that. So let me count 1. Well, I'll put a blue mark here. And let me count 1, 2, 3, 4, 5. So that first red mark now gets a little blue top to it. Then I'm going to count 1, 2, 3, 4, 5. Okay? 1, 2, 3, 4, 5. And I always like to count out the very last piece. 1, 2, 3, 4, 5, just to make sure everything lines up perfectly. Okay? 1, 2, 3, 4 segments marked off in blue within my hole, so I can write 4/4 with the blue. There we go. And now I can label 1/4 right there. Okay. So again, I like the colors because I can do a lot with them as far as referencing sort of what I'm counting up, and I think it will become obvious. But I'll state it here. 1/4. How many 20ths is that? I want to write that as some number of 20ths. Okay. Well, the 20ths are my little segments. So I've got 1, 2, 3, 4, 5 of those little segments right there. So 5/20, I'm writing just beneath the 1/4. Those are both this mark right there, right? And so I did what we might do. Our shortcut technique in our brain might have said, you know, take this fraction to get the common denominator, start doing some multiplication, and you might end up with this, right? But what we're doing here is better because we're not relying on the shortcut where we're just telling students, you know, just do this technique, it'll work, trust me, just do it. Because what if the student said, well, I don't get it though. I don't get why 1/4 is the same as 5/20. You know, teacher, can you show me that? There we go. Right now you see it. I see 1, 2, 3, 4, 5 little segments out of 20. I also see 1, 2, 3, 4. I see 1 blue segment out of 4. So I can really see that those two marks are the exact same number, exact same value. Okay. Without even converting this guy into a different denominator, which I could, we can now start to look at it to find our answer. So this distance right here, that length that I just drew, that little red bar right there, has length 1/4, right? Actually, I have the arrow right there. Yeah, there we go. That's 1/4 because that's between 0 and the 1/4 mark. Knowing this, though, knowing that 1/4 is the same as 5/20 is helpful, though, because I see 1, 2, 3, 4, 1, 2, 3, 4, 5 marks. I'll put little X's there to visualize it. Okay. So now back to the original problem. If I want to do 3/5 plus 1/4, I know that 1/4 is 5 of these little marks. So let's start at 3/5 and then go 1, 2, 3, 4, 5. Right? So I showed the X's there visually. I can do like a jump if I want to as well. So that jump is the plus 1/4. Okay? And so I myself like these number line answers because you locate the answer first before you really know it, right? Now all I have to do is figure out what it is, but I know where it is, right? This mark right there, that's my answer. And so what is that mark? Let's just count up. It's one of the red marks, which means that the denominator is going to be 20 for that answer, right? So I could count up different ways. Let me count backwards, actually, just for fun. 20/20 is my whole, which means this mark is 19, 18, 17. Okay, so 17 marker, not so hot. Here we've got 17/20. All right, and there we go. That will be our answer. Beautiful. Did we ever have to convert this into 20ths? No, but we could have because the work's already done for us. In other words, if I wanted to, I could count up. Well, let me actually describe two different ways. I could count up to this, count up to that mark and count how many 20ths I have. Okay. Another argument I could make, and again, I'm going to say this out loud, but everything I'm saying, if we wrote down, could become a valid argument. Another argument I could make, and this is where what you're arguing, I think it was written homework 3, when you're talking about how to form equivalent fractions. Where am I going with that thought? Oh yeah, so our original, we had our whole was split into 5 equal segments, and then this was 3 of them, right? So I had 1, 2, 3 black segments. When I added the red marks, what I did was take each of those original segments, which is a fifth. So I took each fifth and split it into 4 equal pieces. And so what that did was that's what created 5 groups of 4, which gave us 20. Right? So each black segment became a group of 4. We had 5 black segments altogether, so 5 groups of 4 gives us our denominator. What is my numerator here? What does that indicate? That indicates how many of the original black marks or black segments I shaded or collected. Right? So I've got 1, 2, 3 original marks, original segments. Each of those segments also became a group of 4. Right? That was the same split. Those 3 are really just 3 of the 5 black segments. So those 3 became each one a group of 4. So we've got 3 groups of 4, which gives me 12. Okay, so I can argue that 3/5 is the same as 12/20. Again, though, did I So let's think about it. If you were trying to get common denominator, our rule might be multiply the top and the bottom by the same value, right? If we multiply the top and the bottom of a fraction by the same value, we get what's called an equivalent fraction. And so we can explain that two ways. We can explain it by just saying, well, because that's just a shortcut. You know, the 11th commandment is multiply top and bottom by the same number, and you get an equivalent fraction. Or what I did here is I ended up multiplying those numbers, but I did it in the context of an explanation and in the context of our definition, right? So again, I could have written out the sentences. Take your 5 original black segments, split each one into 4 smaller segments, so you have 5 groups of 4, which is 20. As you did that, the 3 shaded segments each became a group of 4. So you've got 3 shaded groups of 4, which is 12 shaded small segments, out of your 20 total small segments. There we go. Okay. However, notice that that conversion was not necessary for this problem because this was my jumping off point. I just really needed to know how far this 1/4 was. All right, and there we go. Okay. Another problem that you might, or that you will see, let me see how long this video is, 16 minutes. There's also subtraction problems on the homework. And so let me do something here. I would recommend for your homework, perhaps, it depends how busy your number line looks. It might be nice to start with a fresh line because your homework, you've got an addition problem, and then you've got a subtraction problem with the same numbers. Okay? In this case, I can do that really quick because we've already done a lot of the legwork. 3/5 minus 1/4. Okay? So if I'm thinking takeaway, right, I'm thinking the takeaway method, which means start at 3/4, basically move to the left this size or that much, and then the spot we land is our answer. That's similar to the way we just did the addition problem. Is the spot I landed was my answer, okay? As opposed to if you rewrite this as missing add end, slightly different technique, which would also work and is kind of fun. Let's think of this takeaway. If I were starting from scratch, what would I do? I would locate 3/5 the same way we did. I'd set up a hole, split it into 1, 2, 3, 4, 5 equal pieces, and locate 3/5. Okay? Then what I want to do is now I want to move to the left, whatever this length is. And in the addition problem, I wanted to move to the right, whatever that length is. So a key step of that was figuring out what that length is, right? And I erased that little red bar here, but we've still got it. So in order to figure out what that length was, we had to locate 1/4 on our number line. But to go from 5ths to 4ths, we had to go find the 20ths in between, right? We had to find the little segments. So we split our 5 segments into groups of 4, got 20 little pieces. Then we collected up little pieces to form the 4 blue portions that we're looking at. And then finally located the 1/4. Once we located 1/4, we counted up the small segments and said, well, wait, 1/4 is really 5 of these little segments, which we're calling 20ths. It's 1, 2, 3, 4, 5 of those segments. So now that we've got all that set up, can I do the takeaway here? Sure. So 3/5, let's subtract or take away 1, 2, 3, 4, 5 of these little segments. So let me, I'll do a black X. 1, 2, 3, 4, 5. That's my mark, right? That's where that gets me. And just like here, I took the jump. I could show that with the jump as well. Oops. There we go. 1, 2, 3, 4, 5 little segments ends me there. What is that answer? Let's just count up. 1, 2, 3, 4, 5, 6, 7 little segments. The little segments are 20ths because there are 20 in our whole. And there we go. All right. So was it really necessary to start from scratch? In this case, I don't think so because everything is still kind of clear. Again, because I'm using different colors, I think that helps drive it all. Remember, as I emphasized, the picture is really good. So there's that phrase, a picture is worth 1,000 words. It's probably like more than 1,000 words going on, right? If I add up or if I collect everything I described as we did this, that's a lot. As long as the explanation as long as the process is clear, so I can look at what you've got and then kind of somehow see where the answers appeared and how they appeared. That's still sort of the personal thing on your end is how to explain that. So would I include maybe a sentence or two or a paragraph or something? You know, as long as it's clear. So one thing I suggested in the past is give your work when you're done. Give it to your little brother or sister or your parents or something, and say based on what you're looking at. Can you see, or is it clear what I did here? Okay. While I have this video rolling, and it's already long, let me tackle, I'm going to erase a lot of it now. Let me tackle the subtraction problem as missing addend, meaning that's our actual definition of subtraction. And let's see how that would work. So I'm going to, because I've done a lot of legwork here, I'm going to leave a lot of my stuff here. Let me get rid of these two answers, because those were the answers for letters A and B. Let me get rid of these jumps here. And get rid of these X's. All right, and I want to show how to approach this as missing addend, because that's, we kind of want to be able to show both. So remember in 107A, a good way of teaching subtraction is both of those ways, because sometimes one's easier than the other. Some students, when you have your own students, some will see one way, they'll be more comfortable with one way versus the other. Alrighty. A lot of folks sometimes criticize Common Core, which is where a lot of these that's what we're teaching basically here, and they call it like new math. And a lot of angry parents on Facebook say, my kids are learning all this new stuff, they changed math. They didn't really change math. We're just trying to explain it in more clear ways, built from the ground up, or the foundation up, and make it all definition based. So missing addend says versus takeaway. Takeaway says I had 3/5, of $1. I spent a quarter of it, so I lost some money, and then where you land is your answer. Missing addend is basically missing factor. So we take this. I always drop it down so I can keep everything straight. So 1/4 plus question mark equals 3/5. Okay. And again, that's not new. So the same folks, the same angry parents on Facebook who claim that this is new math, this is old math. If you ever worked at a cash register, and you guys are pretty young, if you ever did have a job like that, the cash register is computerized probably, and somebody's buying something for a certain amount, and they give you a $20 bill, so you just type in 20, ching, and then it tells you the change, right? But the old way of counting back change was missing addend, right? If I bought something for $9, or if I was a cashier, I used to work at Blockbuster Video. If I was a cashier and somebody was renting something or paying a late fee, let's say, for $9.37, and they gave me $20, there was computerized. This wasn't that long ago. The register was computerized, but if you didn't want to key it in or something, or you just wanted to figure it out, you wouldn't do 20 minus. You wouldn't do this, right? 20 minus 9.37 and start crossing off zeros and borrowing and doing subtraction in your mind. I really doubt you would do that, right? In your head, because how are you keeping track of everything? Instead, you're kind of doing missing addend. In the sense that you count back up the change until you hit 20, right? So you'd say it's 9.37. I'm going to add back their change until I get $20, right? And so how would I do that? I would say, well, let me give them 13 cents, right, to get an even 9.50, right? So 13 cents plus maybe another 50 cents to get up to $10, right? So so first I sort of found a round number there, then the 50 cents, and then once I'm at $10, just give them $10 back, another $10 bill. So now I know to give them 10.63 as change, and that was really quick, right? I just counted up. I didn't really perform subtraction. I didn't perform takeaway. I just counted up, which is missing addend, and so that's not really new math. That's old-fashioned math. It's sound mathematics. Yeah. Okay. So anyway, let's tackle this problem. So if I were going to do this problem, if I didn't already have all this work, then I would want to set up a number line and locate 1/4 and also locate 3/5 with respect to one another. So same way we did here. So whichever one you locate first, it doesn't matter. However, ultimately you're going to have to split up into smaller segments. In this case, 20 will do. And yeah, so our usual method, same thing we did earlier. You'd want to locate 3/5 and locate 1/4. Okay. And by doing that, we'd have the even space marks the 20th. So all these little red marks would be here. We wouldn't necessarily need to know these things anymore, or acknowledge that we know those things or anything like that. Okay. So the way missing addend works is, remember when I did takeaway, I had 3/5 was my starting position. So for takeaway, this was your starting position, and then the takeaway was the jump. I jumped backwards a length of 1/4, and then the answer was wherever I landed. Okay, so that's different than the way missing add end works. Missing add end, this is my starting place, SP, starting point or starting position. This is my ending point, 3/4, let's say EP, for ending point or ending position, and the length of the jump is my answer. All right, so in other words, here, let me count these individual marks. So I'm going to go 1, 2, 3, 4, 5, 6, 7 of those marks. All right, so I started at 1/4, I added back up or jumped forward until I ended at 3/5. I counted up 7 marks. What are those 7 marks? Those were 20ths, right? Because those were the small marks that we had. So 7 20ths would be the answer, and that's visible in the jump. So in this case, starting point, ending point, the length of the jump, or the number of jumps, is your answer. Takeaway, you've got a starting point, and then you take away the jump, and then your ending point becomes the answer. Okay, so different ways of interpreting it. But we had the same thing, right? When we did takeaway, so for takeaway, we used the fact that the 1/4 was 1, 2, 3, 4, 5 of these little segments. So we started there, we took away 5, 1, 2, 3, 4, 5. And then the answer now was this mark right there, which on the number line, that guy's located as 1, 2, 3, 4, 5, 6, 7 20ths. Okay? So a little bit, I don't want to say confusing, but there's sort of different stories going on depending on which method you choose here. But they both work, and they're both mathematically sound, and they're both valid. So I would probably, if I were on your end, try to at least be comfortable with either one. You know, if you had to show one, that you could, but you can do either one for the homework.